Good evening, dear friends. In this video, one can clearly understand and visualize the complete lecture pertaining to air compressors and nozzles. Anyhow, in this video, I will not cover the complete concepts pertaining to compressors and steam nozzles, but I will be highlighting the epigrammatic overview of air compressors and steam nozzles. Anyhow, in the course applied thermodynamics, to whichever universities it is concerned, normally air compressors and steam nozzles come to one category. Anyhow, in the previous videos, I clearly mentioned that refrigeration and air conditioning comes to one module. Next, air standard cycles and internal combustion engines come to the other module. Very similarly, one can clearly comprehend the theoretical aspects of air compressors and steam nozzles in one category. Initially, let me tell the synoptic overview of air compressors. What are all the things one has to study for the assessments or examination? Let me clearly tell out. Initially, when a student takes up in learning air compressors, make sure that he or she should be clearly aware of the definition of compressor. What exactly is a compressor? Yes, the answer is very obvious or evident. It's very straightforward also. Compressor is a device that has the potential to increase pressure. You all know that when the pressure of a working medium or fluid increases, what normally happens to volume? Volume decreases. Okay, so that is the thermodynamic nature what one has to understand. All right, okay, this is the straightforward definition of compressor. One may ask what may be the brief historical perspective of air compressors, what is the classification, then how exactly the principle of operation of air compressor will be, what are all the derivations one has to learn? Yes, let me tell one by one. Friends, when we just drag the historical perspective, will you believe it or not, this compressor in a very crude form was developed during 50 AD by a person by name Hero of Alexandria. You cannot call him as a scientist or an inventor or a promulgator or a discoverer in a very colloquial context person. So Hero of Alexandria is really an hero. Why? Because he has done stupendous work towards fluid mechanics, thermodynamics, heat transfer and turbo machinery. In the area of thermal engineering, his contribution is absolutely phenomenal. Okay, so starting from 50 AD, you just imagine till now there are absolutely different versions of compressor. But in 1650, a scientist by name Dennis Papin developed a compressor. Later, after 1850, Victor Cope invented the accurate form of air compressor. Okay, this is the brief historical perspective of compressor. You will ask, what sort of compressor will be? Will it be only reciprocating or will it be positive displacement machines? Friends, usually compressor of any nature will be reciprocating, or it may be rotary, or it may be diaphragm type, or a scroll compressor, or a centrifugal compressor. So you can make out what exactly the principal classification of compressor. So what is the principal classification? Reciprocating compressor, rotary compressor, diaphragm compressor, air bellow compressor, then very preferably centrifugal compressor. But in the course thermodynamics, a student will study about reciprocating air compressor, But in the case of turbo machinery, one will comprehend about axial and centrifugal compressors. But now in this video, I will cover about the epigrammatic review about air compressors, mainly reciprocating air compressor. Normally, what is this air compressor? Air compressor, as I clearly mentioned, it has the potential to increase pressure and decrease volume. But what exactly is this reciprocating air compressor? Anyhow, our focus is on reciprocating air compressor. Okay, in this video, it will be comprehensively emphasized. Reciprocating, the term clearly indicates in that compressor there will be piston. The principle of operation of an air compressor will be almost to that of a internal combustion engine. You all know that in an internal combustion engine, one finds a piston, connecting rod. Very similarly, in the case of reciprocating air compressor, there will be piston. So, depending on the reciprocation of piston or connecting rod, invariably reciprocating air compressor functions. So, remember friends, mainly depending on the reciprocation action, air compressor will function. This is the brief theoretical aspect of air compressor. Then what may be the applications? You all know that applications of air compressor are absolutely expansive. It is used in industrial purpose, precision instruments, then heavy duty industries, power stations and whatnot. Compressor is mandatorily required. Okay, we are just dragging about the theoretical detail of reciprocating air compressor. We came across the definition, brief historical perspective, then the principal classification of compressors, then the theoretical operation, principle of operation of reciprocating air compressor. But analytically speaking, what a student has to study, that is what the question you will be asking. Friends, to study the analytical aspects of reciprocating air compressor, please bear in mind 4 derivations are important. When you practice those 4 derivations, I can promise that solving any problem on air compressor will be very easy. Okay? Alright, let me enumerate one by one. The first and the foremost derivation is to derive an expression for work done by a reciprocating air compressor of single stage without clearance volume. Initially, we will take up the PV plot wherein we depict the thermodynamic processes. Okay. So, what is that expression? Ultimately, one has to embark on delta W or power equal to n by n minus 1 P1 V1 into P2 by P1 to the power of n minus 1 by n minus 1. Friends, anyhow in the previous video it was clearly accentuated that to learn gas turbines, refrigeration, compressors, which is the sole thermodynamic relation one has to remember, temperature pressure relation. Okay, so T2 by T1 equal to P2 by P1 to the power of n minus 1 by n. That is very, very important. Okay, to solve any problem, you will be using that. Why we are using that? Why? Because as I clearly mentioned, in the case of heat engines, compression ratio is important. But in the case of turbines, refrigerations and compressor, invariably pressure ratio play a dominating role. So, even in the expression for power or work done, you find P2 by P1. What is that? P1 is the suction pressure, P2 is the delivery pressure. So, friends, initially you practice that. What is the next derivation? To embark an expression for work done by a single stage reciprocating air compressor with clearance volume. Earlier without clearance volume, this is with clearance volume. After the derivation, what will be the expression? Very simple. N by n minus 1 P1 V1 minus V4 into P2 by P1 to the power of n minus 1 by n minus 1. What is the small change you can notice? When you take up the expression for work done without clearance volume, we directly write P1 V1. What is that V1 there? V1 is the initial volume. But when you take up the expression for work done with clearance volume, we write P1 V1 minus V4. What is that V1 minus V4 clearly indicating? It is the magnitude of clearance volume. Okay, so you please bear in mind, thermodynamically speaking, that V1 minus V4 is called actual volume of air or free air delivery. So these two derivations are damn important. So without this, you will not be in a position to solve any problem. So once these two derivations are very much clear to you, you don't find difficulty in taking up the next derivation. What is that? To derive an expression for volumetric efficiency. Okay, friends, when you get the expression for volumetric efficiency, it is the function of polytropic index N, pressure ratio P2 by P1, and you have something called clearance index or clearance factor. Okay, so bear in mind, the expressions for work done with and without clearance volume are very important. Once when these derivations are very much clear to you, you don't find any problem in solving reciprocating air compressor problems with these. I can promise you. So you don't find any difficulty. So these three derivations are damn important. Alright, so till now we have dealt with single stage air compressor. You may question, is there any concept called multi-stage air compression? Yes, friends. Anyhow, for undergraduate level, we deal with two-stage air compressor. But once when two-stage compressor is comprehended, multi-stage air compression can be dealt. Okay? Bear in mind, for a UG level, single and dual stage compressors are very important. Once when you come to dual stage compressor, what is that actually? What is the difference? Stage meaning number of cylinders incorporated. Anyhow, when we learned gas turbines, did we not deal with intercooling? What is that intercooling? In between low and high pressure cylinders, one finds a component called intercooler. Okay, the same idea here also it will be portrayed. So what is that actually? Two-stage air compressor. Two-stage air compressor comprises low pressure cylinder and high pressure cylinder. So in between low and high pressure cylinders, one will find intercooler. Okay. Ultimately, the expression for power delivered by a two-stage air compressor will be 2n by n minus 1 P1 V1 into P3 by P1 to the power of n minus 1 by 2n minus 1. Friends, you may ask why 2n divided by n minus 1? Once after the derivation, the number 2 depicts what? Two-stage compressor is being used. Two cylinders are used. Okay? But for single stage, we wrote P2 by P1. What was P2 by P1 there? It was pressure ratio. But here, we are using two cylinders. When we use two cylinders, we deal with three pressure. When we deal with three cylinders, we deal with four values of pressure. Bear that in mind. Okay. So then the concept of multi-stage compression will be very easy. So friends, for the expression for power delivered by a two-stage air compressor, we find P3 by P1. P3 is the delivery pressure, P1 is the suction pressure. So this is all about the syllabus which is encumbered for the UG syllabus. Irrespective of any university in the course applied thermodynamics, this is all one has to learn in reciprocating air compressors. Alright, when these derivations are absolutely clear to you, as it's already being emphasized, the variety of problems on air compressors are very easy. I can promise that any layman, any average student or a mediocre will be in a position to practice it. Okay, in the same module, which is the other subtopic I have to take up, it is steam nozzles. Friends, anyhow, refrigeration and air conditioning, it is studied in one module. Gas turbines and jet propulsion, they are dealt in the other module. Then air standard cycles and IC engines, one module. Similarly, reciprocating air compressors and steam nozzles. You will ask me, Anyhow, you have given an epigrammatics review or the synoptic overview for reciprocating air compressor. Then what will be the suggestive tip for nozzles? What are all the things one has to study? Friends, steam nozzles, it is very easy. When you deal with air compressor, learning steam nozzles will not at all be a problem. Why? Because let me tell you the clandestinity. What is the open secret there? When you deal with compressor, you will not give emphasis for velocity. We want pressure to increase. But in the case of nozzle, what normally will happen? Pressure decreases, but which will intensify or augment? It is the velocity. Okay. Anyhow, in a learning fluid mechanics, one has come across flow measuring instruments, namely venturimeter, orifice meter. Have you not seen to a nozzle there? Which are all the portions one can see in the nozzle? Convergent cone, divergent cone, convergent divergent cone. Okay? If you learn the theory very meticulously, I can promise that learning the derivation part and problems will not at all be a problem. Okay? So friends, please bear in mind, once after knowing the principle of operation of nozzle, one has to practice the derivation for the velocity developed in a steam nozzle based on the portions convergent and divergent cones. Remember, in a nozzle, what will happen? We expect tremendous velocity to develop, but there should be decrease in the magnitude of pressure. Okay, that is what the emphasis we give. Then once when the derivation for the jet velocity for a nozzle is done, the only variety of problem what we can encumber for the UG level is the calculation of velocity. Okay, so this is a small topic or a module what students find in applied thermodynamics. Okay, so this is what you have to learn for the assessment or examination pertaining to the topic reciprocating air compressor and steam nozzles. Okay, that is all the information being recorded in this video. Thank you very much. Good luck.